I'm just gonna get the sound volume right. Give me one quick sec. It's the wrong one. Hello to everyone online. So just while I'm getting this last bit of audio sound set up, let me know online if anything sounds wrong or bad. And yeah, I really need to address the first point here. I'm not Yu Chao. Yu Chao is not here today. I can hit record. Okay. So yeah, Yu Chao's not here today. So the background is that COMP1531 this term's run by Yu Chao. I've looked after COMP1531 in previous terms, and because Yu Chao is quite busy, I am taking a few lectures this term for Yu Chao while she's busy, essentially. So that includes week 4, that includes Wednesday of week 5, that'll also include week 7, not so much week 8. So you're going to have to put up with me for a few weeks at this point coming up. I imagine, I'm not particularly sure all the details of what goes on in the course this term, though I imagine you've all had to hear my voice before when it comes to the iteration videos, because I think they've been reused. So I might be somewhat familiar to you there, at least. And yeah, that's pretty much most of the introduction. Again, in person, feel free to raise questions there. If you're online, just post on the YouTube chat. That's where we can chat, just on the YouTube chat. Before we get started, though, are there any questions today people have about the course so far? Nothing on your mind? Got a few people working hard away on iteration 1, it looks like. How's iteration 1 going, guys? Yeah, you look very busy on it. That's good. So obviously iteration 1 is due this Friday. Compared to iteration 0, it's going to feel much more, I guess, difficult. It's still not the hardest thing in the world, but it's certainly easier, harder than iteration 0. So hopefully that's all going okay. Now, one of the things about the week 4 content that I'm not really going to be able to sell you all on very well is that this content is directly relevant to your iteration 2 next week. It has nothing to do with iteration 1. So if you're someone who doesn't really want to be here, or you're stressed, or you have other problems, or you're watching this recording later and it's Thursday of week 4 or whatever, you can easily watch this later on. But the flip side of that is that the content in these 2 lectures this week, in particular the one on Wednesday, is one of the most important lectures in the course in terms of understanding iteration 2. And iteration 2 is really where things start to get interesting and challenging for you, if that makes sense. So iteration 1 broadly is still a breeze. The way we often think about it with students is that iteration 0 is really just like teaching you how to use Git. Iteration 1 is getting you familiar in a very easy way with the whole testing implementation process. But what you're doing in iteration 1 is still relatively straightforward. It's a bit of a coordination game still. And then iteration 2 is where you actually go and build something that is semi-functional and a little bit more difficult, and it'll test you a little bit because it involves TypeScript, which Yu Chao talked about last week. It involves this stuff we're talking about this week. It involves linting, which is also another point I should point out. So I think Yu Chao didn't get to the linting lecture last week, so either we're going to get to it at the end of Wednesday if we have time, or if we don't have time, Yu Chao is going to share around a pre-recording from a previous term with you. But for now, we're going to focus on 4.1 today, which I'll get into it. Again, if you have questions, post on the YouTube. You're all very shy and have nothing to say, which is totally fine. I'm okay with that. Now, 4.1 this is a funny little lecture. It's called Advanced Functions. And what's funny about the lecture is in some ways it's one of the least 1531 lectures in the course, because 1531 is a lot about teamwork and group work and testing, and this is actually about features of programming languages. It's very kind of boring technical stuff, but it is important because it helps us understand some of the other parts of JavaScript we're going to use later. So there are languages you've learned like C. Many of you know C by this point, naturally, and it's a very structured, simple language. It can't do too many complicated things. But there are other languages out there like JavaScript or like Python, where they are, that we call them scripting languages or higher level languages. And they have a lot of features and capabilities in them that allow you to do cool stuff with it. And most of that you wouldn't have seen so far, because what you're really doing with Node.js and JavaScript so far is just like writing C-like code, You got functions and arrays and objects, it's structs, whatever. It's like all pretty straightforward. But before we get on to 4.2, the fun stuff, we need to talk a little bit about how functions work in JavaScript. So high-level languages may have powerful methods. That's kind of what I've said before. And we're going to be talking about these things generally. We're going to be talking about function syntax, first-class functions, higher-order functions, callbacks, these kind of words. And you'll see these in different programming languages, not just JavaScript. The first thing we're going to start with is nice and easy, really warm, simple introduction into function syntax. Now, in JavaScript, one kind of annoying thing in a way about the language is that there's 3 different ways that you can define a function. And they all look really similar. Well, I mean, not too similar, but they look similar-ish. And method 1 over here is what you would have seen so far. It's what's going to be in your labs. It's what was in the iteration 1 spec. It's what's probably in a bunch of examples you've seen online. And then we have method 2 and we have method 3 as well as alternatives. Now, method 1 is kind of like when JavaScript was invented, I guess, in like the mid-90s. Method 1 was like what you did. That's just what existed. Though method 2 started gaining some popularity in general as the language developed in a certain direction. And then method 3 was basically a more streamlined version of method 2. Now, I'll point out all 3 of these approaches are identical in terms of outcome. So they all do the same thing when they run, and they all work fine. So there's nothing like super fancy about it. It's purely syntactic in nature. Sometimes we refer to things that are like syntax changes that don't actually change how the program works as like syntactic sugar. Just like sprinkle a bit of syntax changes on top of that, I guess. But yeah, these are the 3 methods, and we're just going to talk about them briefly. Before we do, it's worth pointing out, I know the text is quite small here, but these are the 3 methods with TypeScript. The only difference here being that we've got the type annotation after it. Now, just on the topic of TypeScript, put your hand up if you felt confident with the idea of TypeScript from the week 3 lecture last week. Cool. Very capable friend up the front here. So it's worth reiterating just because no doubt it can't be reiterated enough. TypeScript is a thing in this course that is largely optional. And by that I mean that when it comes to iteration 2 and to your labs, I think there's a lab this week that's on TypeScript, right? Does anyone get any nod? Got one, thank you. Got one nod, quiet nod up the back. There's a little bit on TypeScript this week in the labs. But the thing is, you don't really need to actually do a lot with TypeScript, because the way we've set it up in this course is that if you run code that looks like JavaScript and isn't like TypeScript, generally TypeScript will still take it and run with it. And in terms of the marking in this course, as long as your code compiles and runs, it can fail a TypeScript checker without any issues. And the way that we've helped with that is there's some marks for it in iteration 3 that I think you will get to later in the term. So my point is that when you see code in the lectures or your own code or labs or something with little TypeScript annotations in it and you think, I don't really understand that and it's stressful, just ignore it. It's been set up that way so that you can kind of comfortably ignore it. Go focus on understanding the more fundamental things first. But let's just have a look at, I think I'd probably jumped the gun there. Let me just check. Yeah. So just in terms of these 3 function syntaxes, we're going to unpack method 2 and 3 a little bit later, but the obvious thing you'll notice straight away with method 2 is that it kind of looks like a variable declaration at the start. It says like const sum equals, and then you might expect it to be a number like 3 or 4. And then it kind of jumps straight into a function definition. So the way I like to think about that is you're basically just, instead of you're saying, oh, here's a variable, instead of a variable, it's just a function. And that's actually one of the reasons that this syntax kind of got more popular, is because it standardized the ways we created functions. Because whether you were saying const sum equals 3, the number, or const sum equals a type of function, it's just the same like const, this is a name, and it has this existence over here, whether that is a variable or a function. So that got quite popular, kind of irrelevant to unpack all the details of that. But method 3 was that formalization where you'll see that they did a couple things. Well, the main thing was they dropped the function name, so you don't need to write function there. That's kind of gone, see from method 3. But what they did have to do as well with that is add the little equals side arrow here. So function's gone, equals side arrow is there as well. Why is the equals side arrow there? It seems like a strange thing to do if you're trying to simplify the function, right? I don't have a good answer for you, but what I'll say is that like a lot of that goes down to programming language definitions, because when you define a programming language, it's like writing any language. You could make up your own gibberish language if you wanted to. There has to be rules, right? And the rules might have said that, well, actually, if we say const sum equals this, and then we put brackets here, that JavaScript might have been unable to figure out exactly what you were doing. It might look too much like a little tuple definition or some random scope. So they put that there to like really make it clear what that is. Now, when we talk about the function 3 syntax, one of the method 3 function syntax, one of the cool things about it that also came along with it was the capacity to drop some extra syntax for really short functions. So let's imagine I have a function here called sum. It takes in an a and a b that's a number. And what it does is it returns a plus b. Fairly straightforward. What you can do is if you have a JavaScript function that is simply a one-line returner, you can drop the return and the braces and make it look like that. Now, I need to stress that one-line returner part, because this doesn't, well, it does work, but just to keep things really simple, it's not really for cases where a function doesn't return stuff. It can be, but it's also in particular not really for cases where the function has more than one line of work being done on it. So the point is, if all your function does is simply return a thing in one line, you can drop the brace and you can drop the return and you get something like this. Now, as things start to get this compact, they do look a little funny, right? It's a little bit kind of anti-clean programming to some people, because it looks like, how we kind of teach you throughout your degree a bit, like, code is for humans. You're writing code for people to read. So don't think you're so smart using like random variable names or getting rid of indenting just to shorten things up. But in this particular case, it can be useful sometimes, and we'll see some examples of that later. Yeah, so here's a function. I don't remember, I think this might be the first time you've seen this function, because it gets used a few times in the examples. It's a function called manyString. It takes in a number of times to repeat a certain string. So it's basically saying repeat this string a certain number of times. In this case, it's like repeat the string hello 5 times. So I call manyString, I say repeat hello 5 times, and then it console logs the output. Don't worry about what's inside the body of it for the moment. And you'll see that when I change the function syntax, well, this is from method 1 to method 2. So instead of saying function manyString, I say const manyString, like I'm defining a variable, equals, and then I say function out the front here. And then if we jump to the, let me see what I got here. Yeah, and then if we jump to the method 3 syntax here, you can see that we drop the function and add the equals sign to. There's a question in the YouTube chat that says, how do you export function with method 2 or 3? It's a great question. So you just quickly, we can just kind of chat about that. So in, I can't remember, week 2 lectures, you would have done something where you have like a function like this, and you would have seen that you can export that function that way if you'd like to. That's how you can export it. I believe it's like, or you can say export sum like that as well, off the top of my head. If you have the syntax where it's like const sum equals function AB, then, or the other one, I'm pretty sure it's either something like this, or if it's not, you can still just do export sum. To some extent, whilst you're getting settled, I'd probably recommend that you do all of your exports explicitly at the bottom, just with your programming like that. It'll just kind of make reading stuff easier for other people, because sometimes the exports in line can be a little bit easy to miss. But as always, it's a quick Google anyway if you kind of forget those things. All right, well, that was all pretty straightforward. None of you have too many questions. Very restrained, all of you. So I'll get this up over here. Now, first class functions. This is probably the most important part of this particular advanced function lecture. And what first class functions are is they are cases. Let me just jump ahead a few things. if a language has first-class functions, the reason that terminology is used is it's saying that functions are treated like first-class citizens, which basically means that they're treated like variables, which is where you get a language where you can basically define variables and functions the same way. That's what I was referring to earlier. This is just a name for it. So that method 2 and 3 we saw, that is using the idea of first-class functions in terms of the syntax. And the cool thing is you can just kind of console log these things out too. So for instance here, let's imagine if I just go and grab this piece of code for a second, I could probably just paste it in some random folder here. Should work fine. Oh, where are we? Yeah, let me just paste it here. Yeah, so if I got this little node run file here, I'll just run that, right? Obviously that comfortably just console logs my name out there. However, if I use this one here, what do you expect the console log's going to be? Well, it says function get name. So that kind of makes sense because like in the first case, we were actually just had a variable, but in this case, we've got some kind of function thing. And it's really important to identify to people, there's a difference between these two things. I think this can always trip up a few students naturally because you're not really looking for it, right? Because like this bottom one here is kind of what some people expect it to do, right? Because if you print out the function, because that's all you really do at this point, right? If you've ever console logged something or printed something, you've never tried to print the function. You've often tried to print the result of calling the function. So this is something that you've probably done a bunch, but this is something that's a little bit different. And you can see here, there's no real way to print a function because it's not really like a variable. It's not a string or an integer. So the best thing JavaScript can do is it's got this complicated little object here called a function, and it just kind of prints out some string representation of it that says, hey, this is just a function I have called getName. And that's my function. So it's pretty easy. So both of those things are fine. Now, that doesn't really motivate us yet at the moment. It just kind of says that's what we can do. Not really sure why we're talking about it. That was the definition. Yep. So let's play around with a few more examples first, because in a lot of ways this lecture can be hard to find particularly motivating, given that it's kind of a precursor to the exciting one on Wednesday. But let's have a look at this piece of code here. Now, the first line there called FMTR, formatter for short, that's a piece of TypeScript. You can kind of gloss over that if you'd like to. Maybe it's a good chance for me to kind of quickly recap the TypeScript part of it. But if you just look at this piece of code, and I'll pull it up in the, what's it called? Just Atomic. Yeah, so here's our code. Nice and big for you. Let's just have a quick look at TypeScript, because the code's not super complicated, but the TypeScript part might be new. What you see with this code is what you would need to do with TypeScript to get full marks for the TypeScript part in iteration 3. But again, you don't have to do that now. So let's imagine for a second for iteration 2, or for your lab this week, you get asked to write TypeScript. You could basically, you could basically use that, which just looks like normal JavaScript, nothing too hard about it, and TypeScript would be able to run it fine, and it would not inhibit you. You don't need to understand the TypeScript part of it, but if you'd like to pass the TSC check that Yuchao talked about, then you do need to kind of have the full types there. But often the full types aren't too complicated. In this case, my 3 functions, brackets, full stop, and say hi, have just strings in 3 places, so all I need to do is say in those cases, it's just a string that I'm passing in. We'll come back to the format a bit in a sec as we understand the code. Now the brackets one makes sense. It takes your string, puts some parentheses around it. Full stop makes sense, takes your string, puts a full stop at the end. Say hi makes sense. It says hello, and then it puts your name in there. But it doesn't just put your name in there. This would be a simpler function if all we did was just say hi and we pass the name, and that would be like the others. It would be quite straightforward. But we have this other thing here instead, where what say hi does is actually says hi after basically, and it prints out the result of calling format. the function, and it passes the name into format. However, that's a little weird because we don't know what format is, right? Like, again, in most programming you've done to date, when a function is called, you are generally able to control, like search that up, Command F, Control F, and find that function definition. But in this case, there's only 2 mentions of format in the entire code. There's no definition of format. And that's because what is happening with this say hi function is it is taking in format is taking in a function as a variable in the parameter list. And then we go and see, well, where exactly is it being taken in? Let me just maybe like this, is that, I could keep this simpler for you just to start. Don't worry about that commented out bit. I am calling say hi, I am passing in Hayden the string, and then I'm passing in another function. So in this case, rather than passing, because this is a variable and this is a function, I'm passing them both in like they're interchangeable, and that's why we call JavaScript a language with first-class functions. And when I pass in brackets, okay, so what's going to happen? Well, brackets, the function's passed in. I call say hi, it's going to print out hello, and then it's going to pass the string Hayden into the function format, which in this case is brackets. So brackets gets called, Hayden gets put in it, parentheses get put around it, that function returns, and then it gets kind of injected there. So when I go and run that, which is just this here, which also, just on the topic of running it, so I've just got all the code here. I'm just using last term's code because it hasn't changed and I've got it handy today. But if I go inside, that's not today's one. Let me just double check. Did I do? Yeah, okay. So remember, now I can't just use the node command anymore because these are TypeScript files. Now, this is kind of the most annoying part of the course for me when it comes to talking about it, because it's really easy the first 3 weeks. You just write some JavaScript, you run node. That's what you've been doing so far as well. But when it comes to TypeScript, we have to do a few extra commands, which I'll take you through here now. The funny thing about TypeScript is JavaScript is, Node.js is built on JavaScript. So when you run Node, it just understands JavaScript. Node doesn't understand TypeScript. So I've actually got the code here. It's called FCF format atomic. And if I go FCF format atomic.ts, it does that. It immediately gets caught out, syntax error, because it doesn't understand this, because line 1's a piece of TypeScript. If I get rid of that, it's just going to get confused on the next one. It gets confused on anything that looks like TypeScript. And right now, to get TypeScript working, you basically need to use that NPM library, that TypeScript NPM library. So you've got your basic Node and NPM, and then you layer on this external TypeScript library that is mostly managed, I think, by Microsoft. I think Microsoft mostly kind of sponsor the TypeScript stuff. In the future, though, it probably won't be like that. And this is true for a lot of language features. I would just guess, I'd have a guess, that in 5 years, say, don't trust me on this, I don't know what I'm talking about, but in 5 years, you're going to see a bunch of developers, most people are using TypeScript, and they just say, you know what, can we just spend the time to incorporate TypeScript directly into Node.js? So that in the future, what will happen is maybe 10 years from now, if it's still quite popular, you just go to the Node.js website or whatever, you download Node.js, and it just works with TypeScript. But then by that point, there'll be some kind of newer cutting-edge stuff that people are working on that you always have to npm install, right? And that's kind of the cycle of the development of these languages and things, is that 10 years ago, there was probably a bunch of stuff we're using in Node right now that you might have had to install separately. And we're just kind of constantly developing stuff, and then the popular stable things are getting incorporated into the core, and that's true for a lot of software. So I can't just run it like that. I did need to go and npm install things on this package.json. It has a whole bunch of the TypeScript stuff. And then there's a command here in, oh, sorry, that's package lock. There's a command here in the scripts called tsnode. Tsnode is the, I know this was covered last week, but now instead of running node on my file, it's actually fairly straightforward once you're set up. I do npm run tsnode like that. And it should run my file unless I've screwed something up. In this particular case, yeah, it's upset that I deleted that. So it's running my code. So And remember, TypeScript works by type checking, stripping away the types till it's just normal JavaScript, and then handing it over to Node to run. So Node's always running the code. Like, let's be really clear about that. I just want to reiterate that. It's not TypeScript running the code. TypeScript is a pre-checker to the running of Node. It's always still run with Node, which kind of makes the idea of it really simple. TS Node just does it behind the scenes. So if you wanted to, you could actually kind of break this up into 2 steps. You could type check your code, strip away the types, do both of those with TSC, and then run that JavaScriptified stuff in just Node. But TS Node just like sweeps the pipeline for you. And the way we've set it up in the course is that the TS Node itself actually does very light type checking, I believe, unless I've set up the lecture stuff a little different. Your labs and project will work fine. But yeah, see this? See how I'm getting rid of all the type annotations here? And it still like works totally fine. And I'm only highlighting this even though it's not strictly part of this because it's so important, because when it comes to iteration 2 next week, and even the labs, people can get hesitant and be like, oh, I don't really know how to start it because I don't understand TypeScript. And the point is you don't have to. All we've done here is changed a file type from .js to .ts and changed how we're running it, because we will run it with that. So you don't have to do all this fancy schmancy stuff to use TypeScript. That being said, the TSC command will always fail because the TSC is what's doing the strict checking. Back to our regular programming, you'll see that this program here prints out the brackets. And what's really cool is I can change this from brackets to full stop and notice that I get a different output. So one of the benefits of using first-class functions and passing functions in as variables is that it gives you a lot of variability. It allows you to write functions, because it's funny, you actually understand this without realizing a lot of the time. Like when we write our first functions in programming, we understand that we're writing a general, what do they call it, routine, a general procedure, and we're saying that the actual output from this function will vary just based on a couple variables we pass in. It's just a rule that varies slightly, like a recipe and things where you ask how many people are you making it for, right? Like, has anyone ever used HelloFresh or any of those things? Like meal kits? It's like no one. They give you a thing. They give you a recipe. The same people who get dinners for 2 and dinners for 4. The recipe cards look the same. It just says are you cooking for 2 or 4, and it gives you different amounts of eggs and stuff for each. So it's the same thing here. It's just we're doing it for functions now, not variables. So there's nothing actually really new here. It's just variables are easier to conceptualize because they're just like a thing. They're just like a number or a string. Whereas functions feel a little bit more icky in our heads because it's like, what is a function? I can't really print it out. If you can't print it out, I think things are harder to reason with. But that's what happens there, and you can see that we can just reuse things by calling say hi with Hayden on full stop and say hi with Hayden on brackets, and then suddenly we get an output like this, nice and generalized. Cool. Now, what we have here is the shortened version of it. Now, rather than just show you side by side, I want to take you through it. So let's imagine we have our code here. And I want to go and do method 2 function syntax on it. So what I'm going to do is I'm going to just rearrange how I write this, and I'm going to say const brackets equals that instead. Right? So instead of the function whatever, I'm now onto method 2. That will also work totally fine. No issues at all. I'll get the output I want. If we go to method 3, well, what do we need to do now? We need to drop the function, and then we need to add an equal side arrow to everything as well. Okay, same output, no different. It's just syntactic changes. Great. Now what you also notice about the 3 functions is they're all one-liner return functions. Okay, so what can we do with our one-liner return functions is that we can drop the return, move it back up a line, and we can drop the braces as well, right? Until we get this. And now we get left with slightly shorter code. Put your hand up if you think that's easier to read. Put your hand up if you think it's harder to read. Yeah, good. Good mixed bag of people. There's no real good answer for what's appropriate there. What I would say, just to be like, to try and add some level of objectivity to it, these top two are easier to read. I think to some extent, obviously, like opinions and preferences aside, they're probably easier to read for 95% of people. But line 7, I think, is a bit more debatable. It's a big fat line, you know. And the reason I like pointing that out is because you don't have to always do this, right? It's a little bit of discretion. And I actually, to some extent, I think line 7, you could argue, is a little bit too much there. I think it's just our eyes and our brain. Like, that's a lot of ideas to get in one line. I think on average, most people would probably do that in one line. Like, as if you were like a full-time JavaScript developer, you would digest that pretty quickly. But if it gets much longer too, or there's too many ideas in it, it can get a little bit heady. But something like this, actually, this would be really, really popular to condense down to one line, just because it can actually read pretty comfortably once you're used to it. It's like, oh, I've got a function called brackets, takes in a string, puts the brackets around it. Like, you can kind of skim through that quite quickly. But again, it's really up to you. There's no real rules in the course regarding this. One of the reasons this lecture just exists is because a lot of this syntax is out there on the internet. You know, so as you're Googling JavaScript, you'll see a lot of like method 1, method 2, method 3 function syntaxes. You'll see a lot of these one-liners as well, and it's important you understand how to work with it. But yeah, it can get pretty short. That's the thing, is like JavaScript as a language can become quite concise and clear if you let it. Now, the other thing to point out here, I think it's time, is that the formatter part. So defining types is relatively straightforward for numbers, strings, sure. For things like arrays and objects, the type definitions aren't too complicated. There's all the TypeScript lecture Yuchao went through last week, which is also fine. Though, you know, things like arrays of arrays or objects of arrays and things, they can get a little bit trickier, but a lot of the time you can Google it and kind of look for an example. Also, sometimes I'm sure that if you like, and I got to be careful here, but it's like, you know, ChatGPT as a concept. I mean, I wonder if Google's like Vertex. Is it Vertex? Oh, no, it's Gemini. Sorry. Got that mixed up with something else. I wonder if they'll let me use it without signing in. Damn it. OK, we'll have a look at that later. But whether it's like Google's Gemini or GPT, it's often really easy to actually like punch in something, like, because when it comes to, you know, LLMs and things, it's easy to be like, oh, I can't use it because it's plagiarism and cheating, which is true, and you have to be really, really careful of that. But what I'd say is you've got to use the same discretion that you kind of use with Google. So let's say that you are trying to figure out, you're like, man, I don't know what type format here should be. You know? Like, what should I put here? It's a function and stuff. Well, you would try and Google some generic stuff. You wouldn't like paste all your code into Google or look for like some other student stuff in Google. You're trying to understand the fundamental problem. And it's the same thing here. Like, if you were punching this into a ChatGPT, I would be like, hi, ChatGPT. I have a function that I'm not sure what type should be. And then challenge yourself to try and write this more generally and be like, function hello takes in a number, like, you know, number. Sorry, return num plus 1, right? If you punch that, you know, can I have the TypeScript type for this? I don't want to do it because I don't want to encourage it and get videos of me doing stuff. But if you punch that into ChatGPT, it'd probably tell you, right? And it wouldn't tell you the exact thing that you could use for your stuff. You'd have to digest it a bit. But it's probably a quicker way to get to some of the answers than Google. You know, because you're giving it like a bit more contextual information. Because this will come back and be like, oh yes, for sure, the type of this one is going to be like type X equals number. That'll be what it gives you. And then you're like, okay, well, what's going on here? And then you think about other things you've learned, and you're like, well, this actually is just a function, right? There's the parameters, there's the return type. So it's like, oh, okay, well now I get it. So if I had a thing here, and I'm like, what should that be? Well, I'll just make a new type called formatter, and it'll be what? All of these ones here, they take in a string, and they return a string, and there's my type. And that's how you get the types for functions with these kinds of things. And this is important because there are a few cases in your project, I guess, later on where you'll have functions that take in other functions. And therefore, you know, that's worth knowing about. Sorry, I've just been signed out of my reading all of your comments. Ugh. UNSW keeps asking me to change my password so often I don't even remember it half the time. So Yan Sun on the chat says, I wonder if the form is harder to understand if the function is long. Yes, 100%. You would pretty much never condense down that kind of method 3 one-liner if it gets really long, because it just gets too hard to read. Samuel said, oh, Samuel's already asked that question, so we're all good there. OK, what else do we have? For something more complicated, let's use functions as arguments, but apply it within a loop. Oh, this just keeps getting more interesting. All right, so we've got our brackets function, we've got our lowercase function, all standard method 1 stuff. I've got a list of names. I create another function. Note, the style here is not too great, kind of having all the functions separated by random variable declarations. The function format names takes in a list of, like a string list, and it takes in another formatter, and what it does is it creates a new list, and then it loops through the old list, and for each item it formats it, and then it pushes it to the new list. And then I get a new list. So it's a way of getting a list over here, taking each element, basically passing it through some kind of like rearranger, and then dumping it in a new list. So what you get is 2 lists side by side, and every element, if you went down, has simply been applied by that format function. So for instance, if you're like, I've got all these names like Hayden, Juliana, and Tam, and you would like to format them, then you can simply call that, and it will go and add brackets to them all. And if you call lowercase names, it will go and do the exact same thing. So npm run ts node. So in the first case, we get Hayden, Juliana, and Tam with brackets, and in the second case, they're all lowercase. Nice and easy function. So we've given ourselves this generic function that's able to basically go and mutate elements in a list, which is nice and helpful for us. None of you have any questions today. Sleepy beepy. Who, with a question mark, that's their YouTube name, says, can you abstract the TypeScript away for readability and just prototype everything down the bottom or top, like what you were saying with export? So that question, I think, like if I just focus on this formatter part, what I'd say about separating it out is this is actually kind of what we've done already. If you weren't separating it out, what you would end up doing is kind of just having that directly in there. Because that whole thing where we go type something equals something, that's not necessary. That was actually just to clean up the code a little bit. You could just do this. It's just, I don't really like doing that because I think that from a readability perspective, this starts to get really hairy and stupid when you've got your like function and then brackets and then this and then more brackets and then more closing. And then imagine we had this written like this now. There's too many equals, and do you know what I mean? Like you can't immediately kind of snap in and be like, oh yeah, okay, I see what's going on there. Like even I look at that now and I wrote the damn thing, I'm like, that scaring me quite a lot. So usually for type definitions of functions and anything really that's not just atomic, I think it's a good idea to have it separated out like that, because then it's just a lot easier to read in general. All right, yeah, so we've got our function. We tried that out. Now we're going to do it with new function syntax. Yeah, OK. So if I was to break this up with new function syntax, what you would see is you would see that we have something like this, where we break it all up into one line like that. There's our like one-liners, nice and fun. And down here, we could probably move this further down. We have our console logs like this. Now, the point of showing this one even further is that I think it's taught kind of more formally in other courses, but there's this idea of anonymous functions in programming. And anonymous functions in programming are functions that are defined but don't have a name. It's a little bit of a weird idea. But we kind of understand this from anonymous variables, right? If I just kind of take a pause from what's there and I look further down, imagine I have a function called, well, brackets might be a good example. What have I got here? So let's say I have this, this function called brackets. When I call brackets, I can obviously call it with a string like this. Right. I've got a piece of data called Hayden. It's got a name of st, and I pass it into the function. An anonymous variable would basically be this. You don't think of it like this, but if you do, Hayden is a variable that's simply anonymous. It has no name. I cannot reference it. And the reason is because I only use it once. And if I'm only going to use it once, what's the point of pulling it out into a variable and then passing it into a function? There's no point, because it's just getting used once. We can apply the same thing to functions, where we say, well, actually, if you look at this code, and this isn't really something you can refactor. You kind of need to be the person who wrote the code to understand it. Brackets here, I only use this once in the code. So rather than kind of define it up here and stuff, I'm just going to go and copy and paste that down here like that. I'm just going to, and this is the other benefit of some of the like the method 2 and method 3 function definitions, is that because you've kind of written it in a way that's like constant lowercase equals value over here, it's easier to grab it and kind of copy and paste it down like this as well. So now we don't even need to define them explicitly because they're defined down here. Now, you would only generally do this, you would do this any time a function's only used once as a rule. But if the function was complicated, what you would end up doing, and I'll do this for, say, lowercase, is if I look at the non-simplified lowercase, like this one, right? That's what it looks like when you don't try and reduce it down to a line. You can still copy and paste it in. It just looks like this. So both of what you see here on lines 13 as well as 16 through 18 are different ways of using functions anonymously to cut down on code clutter. And I would say that generally it's pretty common to do that. The only times, obviously you'd never do this if you're going to reuse a function, because if you're going to reuse a function, it needs to have a name somewhere so you can refer to it in multiple places. The only other times you wouldn't do it are if the function was probably really complicated and just made the code hard to read, because then you could just break it up beforehand. But one big benefit of this that might not be obvious is that when you do define the anonymous functions in line like this, it can actually make it really easy to read. Because as a programmer, particularly if the function is quite simple, you don't have to see a function name and then go look it up, right? We're seeing this pattern on various sides everywhere. It's like formatter here. We decided that the benefit of being able to understand what that is in real time isn't worth the code clutter. So we moved it up the top. Whereas the benefit of understanding this in real time might be worth it. So that's how we could cut that down as well. Couple other questions on the YouTube chat. If TypeScript files run JavaScript without any TypeScript actually in the file, does that mean all our files in our project should just be TS files, or both have a .ts and .js for each file? This is all iteration 2 stuff again. I just want to preface that just to not confuse anyone that this has any bearing on what you're doing this week. But in iteration 2, we literally just say to you, welcome to iteration 2. Go change all your file extensions from .js to .ts. Takes 1 minute. It's a simple merge request. Get it in. And then go write code normally. It just happens that instead of using node file name, you have to use npm run ts node file name. That's the full extent of the upfront TypeScript burden that you have to deal with. Catch on YouTube says, if I add tests for that function, should I import type definitions to .test as well? Yes. Oh wait, it depends if it can be inferred. Ignore my initial yes there. TypeScript is very good generally at understanding stuff. And what I mean by that is, in this particular case, I'm not sure if it will in this case. I'm not really in a position to run it. But a lot of the time, TypeScript doesn't need to know what return type a function is because it can figure it out. TypeScript's actually a lot like people in that way. It's pretty good at kind of looking at code and saying, I think I know what you're doing there, so you don't need to tell me what you're doing there. A really good example that you'll see all the time is if you pay attention, when you say something like const name equals Hayden, you don't, like, if this was proper TypeScript, you would normally need to do that. Like, that's like a full, super explicit TypeScript. Yeah, const, I'm creating a variable called name. It is of type string, and I'm defining it to be Hayden. Sure, TypeScript's like, I can see that it's a string Hayden, because I can see what's on the other side of the equals sign. So there's a lot of stuff TypeScript will figure out for you. So someone said, like, if I add tests for the function, should I import type definitions? Probably not. I don't want to say that like universally, but probably not. It's actually often easier with TypeScript to just write your code without types and wait to see what TypeScript complains about. You know, like you would, I don't know anyone who would write code with the types as they go before they run it. The only time I could imagine ever doing that is if you're writing really, really complicated code and you actually want the types there because you're so worried about the code running poorly that you like need the types there for TypeScript to tell you you've made an error. But for something in the complexity of the project, that idea is generally kind of overkill. Adams asked, can you have an anonymous one-line function that returns an object? Or will the squiggly brace be interpreted as starting the function? Yes, you can. I understand what this person's asking. Sorry? Oh, OK, easy. Let's just try that. Let me find our run file. I think you need parentheses in front of it, though. So the question is basically, what happens if I have a function called getStuff, and what it does is it returns, like, you know, name is Hayden, like that. And I call getStuff, or, you know, better yet, I console log it. So if I then go and just run that, this isn't TypeScript, I've just got my old file here. Whoops. So that works. Well, how do we condense that down to one-line function syntax? The problem someone's saying is like, OK, if we drop the parentheses and the return, all that's going to happen, and it's a fair point, is that it's going to be like, that looks like a function that's just written wrong, you know? Because it looks like someone's actually got a function here, and they've just written bad syntax in it. Usually, I think if you put parentheses out the front of it, that's what you have to do. So it's a little bit of like a JavaScript-y thing, but if you have a function and all it's doing is returning an object, you just have to wrap that object in parentheses, which is basically, again, just how the language is defined to help it differentiate itself from a function to do that there. So that's a good question as well. OK, we're nearly about to take a break in a sec. So I'm just having a look here. Anonymous functions, we talked about them. In summary, first-class functions. Yeah, so I don't think I need to go on this front too much. The only thing I would say is that quite often in a lot of programming and stuff, you'll see them referring to callbacks. Callbacks is a term used a lot. A callback is quite literally just a function, any function that is like passed into another function. It's not real. We'll kind of maybe talk about this more in iteration 3. But callbacks are just first-class functions in a nutshell. So if you see callbacks around, just think about a function that's called by another function, basically, you know, deferred later. But again, we'll get into that more in future. All right, we're going to take a 5-minute break, then we'll keep going. get back to it post-break. Who's having a lot of fun? That one person. Welcome. That's good. Who's having a bad time? It's a weird topic. Like, I'll be honest. Like, you know, there's like a part of me that's like, this is kind of interesting because like programming's kind of interesting, and the other part of me is like, this is really boring because like, what the hell is all this really about? But again, you'll just have to trust us that it's all part of the bigger plan. Now, if you found it boring so far, let's get on to some more interesting stuff. Map, reduce, and filter. There are three really important functions that are baked into the core of JavaScript, particularly two, map and filter, but these are the full three, map, reduce, and filter. And they are so useful, and we could have taught you to them today in a vacuum, but it would have been a little bit weird. But with all the stuff we've just spent the last hour covering, it is going to be significantly easier to understand. So map, reduce, and filter are three functions in JavaScript that work on arrays. So this is all about arrays. Has nothing to do with objects, has nothing to do with strings or anything. It's just arrays of stuff. And what they do is they help accomplish basic iterative tasks that you would be doing all the time or will start doing a lot in JavaScript. The first one is the map function. What the map function does is it takes an array of size n and it produces a new array of size n, having modified each element according to a function passed in. Does that sound familiar to anyone? No? You missed that part. You're asleep. That's OK. So it basically says, I will take an array and I will give you a new array that is the same size, but all the elements have been modified. And it looks like this. Now, if you pay attention, what you'll notice is that it's actually, before we even stare at that for too long, it's actually pretty much just the same as this function here. Remember this one from like 15 minutes ago? Format names. It took in a list of something, and then it took in a way to format them, and then it created a whole new list by formatting each element. So that's actually exactly what this is, because this is an extremely common thing to do in these high-level languages, is to take a list and format it across. But there's a nice, easy syntax to use, which is this one here, tutors.map. So I take my array called tutors with all my tutors in it, and then I simply call .map on it, and then I give it a function. So again, just to pay attention, notice how identical that is to, I can use this one here. Does that make sense? So, and if I was to give you a quick comparable, what's happening here is that this way on the screen is how we do it with our custom defined function, which isn't very useful. Or if we just take advantage of the map function that already exists in JavaScript, it would just look like this. We would say names.map, like that. So the map function is there, and it doesn't need any of this custom things, but it does the exact same thing. It loops through every element, and it modifies it in some way. Now, naturally, there are some requirements, like the function that you pass into it has to have one parameter generally, and that has to be the type of what's inside the array. Like it wouldn't make sense if we, for instance, look at this piece of code here. If I was to have a function that took in a number and printed out I+1, right? That won't make sense. That won't work because the function that you're passing into the map needs to operate on each of those list elements. So it would need to be a string. Maybe JavaScript would let it. You know what? Let's just try it out. Let's see what happens. Run it on map old. No, that's the wrong file. I'm in the wrong folder. Map old. Wow. TypeScript figured this out for us. Great example of TypeScript actually watching our back. I don't know what happens if we get rid of the annotation though, because obviously the annotation here is what protects us. Because TypeScript inferred that the type of tutors, it didn't need us, it inferred the type as that. It knows what it is, it can see it. It's a list of strings. But we did have to be explicit there, but if I get rid of it, let's see what it does. Oh, it tried to run it. Oh my God. Look at this monstrosity that we created. What did it do? Well, let's step through it. We had a function here that takes in a number and tried to return, well, it takes in a thing and it tries to return I+1. Now, it didn't strictly crash. It might have crashed if maybe if I just say literally return I+1. Let's see what it does. Probably the same thing. JavaScript is a friendly and evil language all at the same time. It's your best friend and your worst enemy. It's a very strong love-hate relationship. And that's because it helps you do a lot. But in this case, what happens is that you pass in I. I is passed in as a string. I gets to here, and it's a string. Then what happens is JavaScript is confronted with the problem of trying to add a string to a number. Now, it does not know how to turn a string into a number, but it knows how to turn a number into a string, right? Because you just take the string representation of that number. So what it does is it takes that 1, it turns it into 1, and then it says, oh, I have 2 strings now, and it joins them together. It concatenates them together, and then you get an output. Now, this is in a way one of the worst kinds of errors, because when we talk about errors in general, we often say that the best error is one that crashes the program, and the worst error is one that doesn't. Compile errors are the best thing in the world. because nothing has to run. And you can see exactly what's going on. Whereas this is terrible. The program finished and was like, all good. It's like, not all good. It all bad. It very bad. And it's a good example where TypeScript will come in, because if you're writing this and you're like, well, this needs to be a string or a number, TypeScript will catch it and be like, no, something looks wrong there. So that can be quite helpful. But they do need to match up, otherwise there will be problems. But that's a map function. Really cool thing, because you can take an old list and you can take a new list and you'll get those two lists modified. Someone in the chat, Raya says, will we learn about regex? Regex is a shorthand term to describe a markup sort of language, programming language, I'm not sure, called regular expression. We don't cover that in 1531. I know we give you a little bit of it, I think, for iteration 1 around the email or something from memory, unless someone's changed that. But it is covered in a course called COMP1531 in a bit more detail. Though, like anything with programming, if you have the will and conviction, it's not too hard to teach a lot of this stuff yourself. The best thing about doing uni courses is that you're now paying for it for someone to chase you up, so you'll definitely do it, right? But a lot of this stuff you could always teach yourself if you really needed to. So it runs all totally fine. The right-hand side, I actually think what's happened here is, just to be clear, because I've used last term's code, I think I modified one of the files when I was lecturing last term. So that one on the left here, how it says classic, and then it like shows some stuff, and then it says modern. The classic one would actually be what we had back up here, right? So just to kind of contextualize this slight hiccup, this would be classic here. It would be like you write it yourself. And modern would be the one we're looking at here. The better contrast between these two, forget the whole classic modern thing, is more, notice how you get the same output whether it's anonymous or not. So the left-hand side is anonymized function, and the right-hand side is an explicit function, right? Because the right-hand side, the function has a name, has the name called shout. So we pass that in, whereas the left-hand side doesn't. Same effect. It just depends whether you're reusing it. So you generally do the right-hand side again if you felt the function you were writing was too complicated to be kind of inlined, or if you were going to reuse it again multiple times. All right, filter. Filter's the other exciting one. Filter's kind of like map, but a little bit different. Map produced an array of the same size, but changed the contents. What filter does is it produces the same contents, but the array is a different size. Does that make sense? So it doesn't modify or touch the elements. The elements on the way in are the elements on the way out. It's just only a subset of them. The array's a little bit different. Now, if you pass in an array of size n, what a filter function will do is it will output for you an array anywhere between empty and size n again. And if the term wasn't kind of obvious enough, filter, what it does is it goes through an array and it filters out things you don't want. And we'll be able to see that with code here a little bit too. Yeah, I've screwed something up here. Give me a second. Let me just see if I've got an older one. Maybe not. Maybe the code's fine and my brain's just messed up. So again, don't worry about the classic modern. Oh, there's maps everywhere. What is happening here? Two seconds. Okay, that's better. Looks like I've screwed something up along the way. This is what you might call like your old school filter would look like. This is if you were doing it yourself today, right? Like if I gave you a problem and I said, hey, we've got a list of marks, and what I need you to do is give me a new list where you only show me the marks that pass the course, right? you would probably do this. Maybe you wouldn't even do this. You'd probably go and you'd probably write it like this and be like, if mark is greater or equal to 50. Right, like you probably do something like this. I've got a new list. I loop through all the marks. I find if the mark's greater or equal to 50. And if it's greater or equal to 50, I push it to my new list. All done. Now, what we have, though, is an easier way to do this stuff. Rather than kind of have to write all these loops ourselves, we have the same thing we did with map, where we have this filter function where if we take the array marks and we apply filter to it, and we pass in a function, and that function, takes in an argument of that type that's in the list, and it returns something, that it will cut out the ones that don't satisfy that. Now, similar things here. The function has to take in that type that I've mentioned. In this case, it has to be a number. If it was an array of strings, the function would have to take in a string. Also, a filter function returns a Boolean. It returns a true or false, because it is essentially used to figure out whether to keep it in the array or not. So this has to be true or false, but I will get the output that I want here. npm run ts node filter. Cool. 65, 72, 81, 56. There's all of my items. Good, fun stuff. Questions about that? Pretty straightforward. Kind of scary. All right, so filter, not too bad. Focus on the one on the right. Reduce is a bit of a funny one. I was talking to a student about this last time, actually. It's like reduce. The reason reduce is funny is because it makes sense, but it's just not that commonly used. Like I would say for every time I would ever use the JavaScript reduce function, I would use a map or filter like 10 times each. So I don't want to kind of create like a false equivalency here with map and reduce and filter, because like map and filter are just big things. You'll use them everyone here will use them in the course, I'm sure, in some kind of programming. Reduce not so much, but reduce is, like, you think about it conceptually, map is about taking size n to size n with different contents. Filter is about taking size n to size n or less with the same contents. And what reduce is about taking a list of size n with some stuff in it and reducing it down to a single value, always down to one thing in the end. The most common case that you'll see with reduce is to do with summing. Because summing is a pretty easy reduction, and reduce is the same thing, right? Has anyone ever done cooking where they like reduce the liquid, or like some kind of wine reduction or something? It's all the same concept. You're just shrinking stuff down. But here on the left, I've got my students, right? It's an array of objects. So it's an array with 4 things in it, and each thing is an object with a name key and a mark key. And then I've got this number called single, which is 0. And then I loop through every student, and I add their mark to single, and now I've summed up all their marks. That's how you sum up the marks. However, over here, granted this one has some TypeScript added, so it looks a little bit longer, but if you take the TypeScript out, they're about the same lines of code. I have my students, and what I do is I have a sum function. And the sum functions are really, like the function you pass into a reducer is not as intuitive as the other ones. Because a reducer function takes in 2 arguments, which is the previous and the current. What'd you discover? It's OK. You guys are funny. You keep me entertained. What you working on, by the way? Is it iteration 1, or is it something more exciting? Diary? For the course? Oh, right. Yeah, cool. I'm not too across the details of that, but that sounds fun. Diary. All right. Let's talk reduction. I like to explain this the only way I know how to explain things, which is in Paint. 55, 43, 34, and 23. So these are our numbers, right? Now this is how a reduction works. A reduction always has to start with a base, like a 0 or something, right? A starting value 0. And how reduction works is what it does is it goes and takes two things, which is basically the running total and the new value, like that. Does that make sense? And what it gets out of that is it gets 55. And then what it does is it goes and takes the running total, 55, and 43, like this. They're the two values. And it sums them together. And you get 98. And then what it does is it goes and takes the running total, which is 98, and 34, like that, and it sums them together, and you get 132. And as you'd expect, it goes and takes the running total and the next number, and it sums them together, and you get your final result, which is 155, like that. So it's basically just like, it's kind of how you'd sum up numbers in a way. It like starts with nothing, and then it like just starts accumulating them and building them up. But the reason I need to point that out is because if you look at the if you look here, it's got this prev and current. I don't think they have strict naming rules, but it's always the same thing. Prev is always like the running total, and current's like the new thing being passed in. And prev is usually always the type of the atomic value you're reducing to, and current, the second argument, is always the thing in the array. So in this case, we're trying to reduce the marks down to a number. So the prev has to be a number, and then every time we iterate, we're iterating over a student object here, because it's a whole object. And what happens is every time we do that, we simply add prev, the running total, to current.mark, which is the student's current mark. And when those two things get added together, voila, you're kind of doing a running total. And how you call that is you say students, the array, dot reduce. You give it the reducer function, and then you give it your starting value, because every reducer needs like a starting point, right? Because you've got to begin the running total from somewhere. Now, again, not a super useful method. I've seen it used other times to reduce numbers, because often we think about reducing as like, summing, but you can also multiply numbers together. You could be like, what's the product of all these numbers? It doesn't really matter. And so often the examples, even the ones we're giving you in this lecture, end up being like these sum examples. But quite often, you can also realize that min functions and max functions are reducers as well. Because what's the definition of a reducer? It's something that takes an entire list or an array, and it results in a single value. And when you take an array, there's always a minimum and there's always a maximum. Always. So min and max, math.min or math.max, if you've seen them in JavaScript, they are reducers in a sense. And we could write our own reducer to do that. In fact, like if we were to just kind of quickly modify this code here, and you take reduce, you would find that we could write one that's like min takes in the previous, current takes in the student, and what's it going to do? Well, it's going to say, well, return the minimum of the previous and the current, like that. And it will just like loop through everything. Obviously, this isn't, you can do this a bunch of different ways too, right? Like, I'm sure math.min takes in a list. I don't know. Has anyone ever looked it up? I've never looked it up. Smallest numbers given input. It takes in, a big array. Yeah, so just as a fun little example here, let me just butcher this example to be, what would you call it? Like, let's butcher it to be minimum. So I'll call this min. So this should give us the number 23, right? If I run it, it's called reduce. Cannot find name sum. Oops. Oh, don't call that min. Zero. Well, that's a silly one to start with. You'd probably have to start with a very big number, right? Because you always need a starting point. So I get 23. So that's one way to do it, is you could reduce it that way. Now, the other way you'll see online is that you can pass in a list of numbers to math.min, and it'll give you the minimum. But the problem is we don't have a list of numbers, right? We simply have students. Students is a list of objects. Now what I want to show you is you could actually get the same output not by doing reduce, but by using map instead. So if I just kind of like take a break from that, and let's say, you know what, I want to find the minimum mark. What I could do instead is I could say const marks equals students.map, right? And what does the map have to take in? It has to take in the type, student, student, like that. And what it's going to do is simply return student.mark. Now, that might seem a little bit confusing, but let me just print out students and marks like this, and you can see what I mean. So what happens is I start with students like this, but then the map, it takes each student as I loop through it, and it just returns the mark of that student into the new list. So that's what a map function does. It's taken a list of 4 with those objects in it and returned me a new list of 4 with just the marks in it. And then what I could do if I wanted to here is I could now say that const out, which is the minimum, is math.min, and then I could pass in my marks list like this. Now I can't strictly pass it in like that because math.min takes in an array. It doesn't take in an array, it takes in explicit numbers. I don't think it's really covered in the course. You can go and look it up in your spare time. But if we use the spread operator here, that'll solve this problem we have. Where it'll basically break the array up into a bunch of components and then pass them in as parameters. Again, I don't want to probably spend time unpacking that. But the point is that what I've done there is I've shown you that I can use reduce to get a minimum. Or alternatively, I could just use a map and then use a math.min. There's lots of different ways you can do stuff. But whether you were to use a reduce or a math.min, yeah, it's interesting. Would anyone have a preference towards using a reduce or a math.min there? No? Nothing left in the tank? Cool. Yeah, that's fair. You don't have to write as much. Yeah, so that's a great way to approach it because, I think generally this is just harder to understand too. So yeah, it's harder to understand. You kind of have to write some stuff there. This is a little bit tighter, which is good. Sorry, I was noticing it was given real weird sounds. So yeah, both kind of don't matter. This one's probably what I'd lean to just because it's kind of obvious. I think it's a little bit easy to understand. Sometimes you might want to work with the values intermittently. But again, both are fine. The funny thing about JavaScript is it's just not a very performant language. So if you were thinking about this in the context of a more performant language, you would probably have to start considering things more like the benefit of the reducer is that it didn't have to create a temporary array for us. The reduce just took the one array and it just reduced it down. So it actually, from a memory perspective, was extremely efficient. Whereas this one here, we had to go and create a whole thing. So then you can think about it and be like, well, damn, if I've got an array with like 1 million things in it, and they're all 1 million numbers, and each number's like 8 bytes, that's like 8 million bytes, which is like 8 megabytes or something of extra array. But that's not really what we do when we think about JavaScript, right? Because by the very nature that we're using a language like JavaScript, we don't really think about that too much. So 99% of the time, you would just go with whatever's easiest to understand. The 1% of the time, you might think more deeply about it. But again, it's very rare if you're working in a language like JavaScript or Python, you're thinking about that. And if you are, what you're probably doing is you're probably like I was helping this person out. I remember a few years ago, they were working at Canva, and they were trying to write this little bit of JavaScript that what it would do is look for when companies had broken their brand guidelines on Canva. Who's used Canva before? Half of you probably? Yeah, okay, cool. And to do that, they had to kind of search through the whole Canva screen, and it's like a 2D array, right? You can imagine the Canva thing's just like a list of elements that are just 2D arrays. And when you're working on a product that's like Canva, this multi-billion-dollar product, at that point, people might start worrying about those micro bits of memory because it's such a heavy app. Those apps or those websites you use on your computer that are just slow because there's just a lot going on those apps. Like Google Maps can get a little bit clunky sometimes. Anyone notice that? Like if your computer's busy or you're doing lots of street view or you're clicking around, it gets a bit laggy. In those cases is where people might start to get really finicky with this, where that n bit of performance matters. But generally speaking, doesn't really matter. All right, so map, reduce, filter, anonymous functions. I think we've talked about anonymous functions to death, and we've shown that you can use them as much as you'd like. And then here's a cool little example of tying it all together with some console logs. I might pull it up in code, though, because it's a little more fun to look at here. And I'll get rid of the console logs. The question is, print the average mark of the students who passed the 60-mark exam as a percentage. OK, so there was an exam recently. It was out of 60. These are the marks of students in the exam, 39, 43, 48, 24, out of 60. Tell me what percentage of them passed. Right? Now, you could obviously write this a little bit shorter, but let's have a look at how we can use, all of this together. We've got our first-class functions, which use the new function syntax, which we can pass in anonymously to our map reducers and filters. We have here, so first thing we're going to do is normalize the marks. You don't really have to do this. You could obviously skip it, but which basically says I'm going to take each mark, multiply it by 100, and divide it by 60, right? So now my normalized marks are all out of 100. So like I can look at a pass as like a clean 50%. So this is all marks, 50% pass. Passing marks is I use a filter. I go and identify all the normalized marks of people who've passed. OK, so now I have my passing marks in a new array. And then I say, well, the total marks, the total number of students, sorry, or is it the average mark of, print the average mark of those who passed. Sure. So what I do then is I go and sum up all the marks. And then I simply divide the sum of the marks divided by the length of how many marks there were, how many students there were, to get me the average. And then I just console log the average. So again, you could definitely cut this down more if you just kind of did this instead, just out of 30. But the point is of all this that to people who are programming in these languages, this is fairly readable. And what's nice about it in a way is that sometimes, because you're able to express things like simple actions in such simple ways, in some ways this can actually be really easy to read. Like as in, oh, take the marks. OK, I'm clearly making them out of 100. OK, I'm clearly filtering out everything that's below 50. OK, this looks like a reducer. All reducer sums look the same. They all look like that. A, B, A plus B, 0. And then there you go. There's your average mark. I don't know what the average mark is. We can check. 68.5 is the average passing mark normalized out of 100. Maybe that should be in the question as represented as a mark out of 100. But still very interesting. Any questions about that? Otherwise, we're moving on to our last thing today. My diary people, do you have any questions? Nothing? OK. Worth a shot. So there's a diary in the labs now. Is that what's going on? You have to Cool. That sounds fun. Is it a nice break from programming? It's fine. OK. I know that tone. Don't worry. All right. Higher order functions. Last topic of today. I think this is probably this is important stuff to know as a developer. But in terms of to the course, it's probably the least relevant and some of the harder ones to grasp. So if you kind of lose steam at this point, I wouldn't stress too much. Let me just pull it up for myself. All right, I've got 3 functions here. They all take in a name, like my name. Anyone's name, doesn't really matter. And one's called pass, credit, and distinction. Congratulations, PS, CR, and DN. And depending on the function you call, changes the message you get. It either says congratulations, Hayden, on your pass, or your credit, or your distinction. And pretty straightforward. Right now, your program urges, the one that makes you want to write nice code, what does it want to do right now to clean this up? Nothing? OK. I know what you're thinking. I just know you don't want to talk, which is fine. we could try and separate out the strings, right? You see a lot of repetition. You know repetition is bad. So we might separate it out like this. And in fact, this isn't even using any kind of first-class functioning stuff. This is just something we could have done yesterday. We create a wrapper function called congrat wrapper. Again, I'll pull it up in the code just so it's a little bit bigger to see. That says congratulations name on your result. And then we simply create these same functions here, congrat mark pass, congrat mark credit, and distinction, that just pass in an extra variable to that function. So abstraction 101, repeat ourselves less, centralize that repetition so that if we change the string, it changes in many places and we don't accidentally cause problems everywhere else. Easy. We could take that further if we wanted to and use the new function syntax. Pretty simple. Just changing that around. But this is where things can get kind of more interesting. So what I've got here is an example of using what we might call a higher order function or a higher order component. That whole higher order component, higher order function thing is a bit of a mysterious term. I like to think about it as function factories, because that's what they are. We're writing functions that return new functions. This is something you, again, probably haven't done throughout the programming you've seen before, where you write a function that returns another function, because pretty much every function you've probably written so far will either return an atomic, we call them or not even an atomic, like return a variable or data, I guess you'd say, like an object, an array, a string, a number, or it will return nothing. Makes sense. But you've never had it return a function. I don't think you've probably ever written a function that says like say hello, and well, most of you wouldn't have. And then what you do is you say, well, actually, I've got my new function here, and that is going to take in nothing, and then it is going to console log hi, and then I'm going to return new function. So if we just focus on this example at the bottom here, this is a stupid function, but this is a function that returns another function, right? You call it, creates a function, returns a function. I could make this even funnier, and we're just kind of exploring here. Instead of this, because all I'm doing is defining something, then returning it, I could, just like if I said, you know, const I equals 1, and then I said return I, right? What's your brain want to do there? It wants to convert that into just return 1. You know, like this. So let's apply the same thinking to the new function and say, well, I'm actually just going to return that. So now we've got a function, and all it does is return us a new function. And if I was to take that, and let's just use our sandbox we had at the start of the course here for a second. And maybe I'll simplify this down again for a sec. I think this stuff's very heady, and I've had to explain it a bunch of times, so I'm slowly trying to do better at it. If I call say hello, it console logs hi. Sure, makes sense. What happens if what function say hello does is it returns me a function, and all that function does is console logs hi? Well, how I have to work with this is different now. I have to say like hi equals say hello, and then I have to say hi. And I think this is really important here to stare at this for a second, because the function say hello needs to be called in order to return to me a new function. And that new function is captured in hi. So at the end of this function call, hi is a function, and that hi is simply this here. And then I call hi like that. Right? I can see all the sleepy, hungry faces. Let me help spruce you for the last 8 minutes, right? Welcome back. So I've got my little function here. It says hi. It prints out hi like that. That's the concept of it. Why does that seem particularly useful? It doesn't right now. That's OK. But if we go back to our example here, let's think about how things have evolved from this to this, because they both do the same thing. What's happened if we just focus on the first 6 lines? I've created a function called generate congrat mark. And what it does is it takes in a mark string, like pass, credit, or distinction. And then what it does is, and if I could rewrite it like this too, it returns a new function, right? It doesn't return a value like 5 or a string like Hayden. It returns a function, and that function's job is to take in a name like Hayden and print out or return congratulations on your mark string like this. In some senses, if I just rewrite this for a second as a console log, I think this might make it a little easier because it is less, there's less returns floating around. But yeah, generate congrat mark, it returns this new function, and all that function does takes in Hayden, prints out congratulations Hayden on your whatever. And what that means here is that when I want to actually create many of these functions that are, very similar, I can simply say, well, yep, congrat mark pass is just generate congrat mark with pass. And just to be clear, what this will do, and I'll write this in comments, is that this line up here will have then become the equivalent of this. I'll just copy and paste it, because that's what it does. It literally returns this. It just does that, except naturally, it took in a mark string like pass, so this got changed to that. So we've basically written a function factory, if you will, that generated this. I don't want to say generated code, because I think that can be a bit loaded a statement. But what it does is allows us to do that, where I can call the generate function, and it will actually create 3 of those functions for me that I can then go call later. Again, it's something you might come across in some of the coding. It's not really something I would stress particularly about. For me, this is more nearly everyone, like the vast majority of people I see, once they end up out of uni, have to come across these kinds of functions that return functions at some point. I don't think it comes up a lot in uni, but it ties in really well to all the stuff we've just talked about with first-class functions and things being passed in. So I think it just works really naturally. But yeah, let me just look through the rest of this. The rest of the examples are just cleaning up syntax. In particular with JavaScript, because there's a chance that probably I don't know, a quarter of you at least are going to be working with JavaScript full time in the next few years, would be my guess. What you'll see is that, as you clean up this code here, this is kind of where we ended up. Function that returns a new function, and that function returns some data. Sometimes you'll see code on the internet in particular condensed down to this. I find this to be sinful code myself, but that's only because my brain is made of peanuts most days of the week, and I don't do very well at grasping what this is. Because these two things are the same, because what they've done, geniuses, is they've said, well, yep, this one here, it's a 1-line return, so we'll just go and replace that. Cool. And then they've gone and said, oh my God, it's another 1-line return. We'll just go and replace that. Beautiful. I hate this code so much. It's and I mostly hate it, not because it's long. It being long kind of sucks, but I hate it because this doesn't scream out to me, oh my God, it's a function that returns another function. And even though I know what it does, I still stare at this right now, and I feel a bit of pain inside me because it's just weird. So you might see code like that. If you ever see this kind of double equal arrow thing, you've basically come across someone who's written a function that returns another function, because what they're saying is, hey, my gen congrat mark is a function, and what it will do is it returns you a new function that you are able to go call later. Don't ever write code like that. You can. It's just my opinion here. That's not anything important. But that's what it actually is, and I generally find that is just going to be a lot clearer to read, unless you're super proficient in the whole thing in general. All right, that's don't click that link. Actually, that might be the wrong link. Not that any of you sound like you will, so it doesn't matter too much. Any questions before we wrap up today? Cool. Digest that. It's not hard, but it's very finicky. It can be confusing. I'm glad we got that uninspiring lecture out of the way. When we see you on Wednesday, we're going to be talking about HTTP servers, which is one of the more exciting things you'll probably do in your undergraduate degree. So